etc. And my focus is Azure and multi-cloud security for the most part, which obviously this overlaps with. But before I get into some of the more slightly more technical aspects of this, I feel like maybe I have to go through what might seem obvious to some of you, right? But so why is it important to have security development practices? And you'd be surprised that this does need to be said, because a lot of times people are just about speed, and may ignore a lot of other factors when they do this. But you can't really wait any longer to address security. So it really takes well, according to this report, State of the Software Supply Chain, it only takes around 3 days for a hacker to exploit the vulnerability. And this doesn't even refer to like what's called a 0-day one that's out there in the wild, really knowing about pretty much anything. If you just leave it up there, no matter what it is, within 3 days, someone's going to find out, right? So you basically need to shift left, which, if you think about that, and none of them like the marketing term, but it just mainly means you need to build security into the overall workflow, right? Make sure it happens early on in the process. So attackers as well are doing this, and they're compromising upstream dependencies, engineering systems as well. So the actual source where maybe you're getting your software libraries and all that, they're doing the same thing. They realize the importance of that, and attackers are also, kind of shifting left in their attacks, right? So the result is, attacks impact software development environments and your entire software supply chain. So, and if you think of some recent examples, so Log4j, a very recent one from, I think it's end of last year. So most people when they're developing software are using open source libraries. Nothing wrong with that. Microsoft uses them as well, of course. But this one, Log4j, was a very common one used. It was open source logging library used by a lot of applications and services across the internet. Before that, SolarWinds, right, it's another to digital supply chain attack where, SolarWinds was kind of the weakest link. They got exploited, and that exploit kind of propagated through everyone using SolarWinds. So basically, you don't want to be like SolarWinds, right? You want to make sure you have secured access to your source code, you've employed defense in depth, and good security practice to prevent yourself from being a victim of a supply chain attack. And a couple more, if you look at the threat landscape changing, it's not, you have to think about what is actually being kind of attacked today, right? So these two recently, one called CodeCov, right? So for CodeCov, an attacker targeted their development workflow and their software supply chain. So they were able to get access not just to Google Cloud storage account, right, but also upload a new image to thousands of builds, and by image, like a software image, to thousands of builds, and scan their entire software supply chain, right? So when they did that, and then people using this, so those images again propagated throughout, it just keeps going wider and wider when that happens at the source, right? So and they'd scan their entire software supply chain, extract even more secrets, and the breach got even wider. And then Electronic Arts, they had one where their source code was stolen due to basically just stolen cookies, which contained login information. So they didn't have the appropriate secret or identity protection needed, and those vulnerabilities became an easy target. And like I mentioned, Log4j, which is the open source library, right? So that vulnerability, because it was a popular logging tool, in the biggest Java library, I think it's from the Maven repository, the biggest repository. So that basically allowed an attacker to make insecure JNGI, which is a Java naming and directory interface lookup feature, and exposed by that tool. And so it was an exploitable feature, and it was enabled by default in all of these versions of the library, and everyone was using this library. And because the library itself was vulnerable, they were vulnerable, right? I mean, you can't necessarily protect yourself from this all the time, because there are 0-day attacks and the vulnerability gets noticed. But if you've got these controls in place, as soon as you need to have some way to either control access to that, fix it as soon as it happens, scan these codes, etc., to kind of prevent yourself from being a victim of those kind of attacks. Or at least if you end up being inadvertently a victim, you can kind of fix it as soon as possible. And again, so the whole shift left, and a bit of a marketing term maybe, but again, integrating security as soon as possible. So by doing that, we have just some stats up here. I won't spend too much time on this. So 80% reduction in incidents by making sure security is part of the development process. If you look at the security cost to fix a defect in production versus development, which is, I think, the biggest one. So it's so much cheaper to fix a defect at start than if it's going live, it's going to cost on average about 60 times more to fix it. And And if you think about the cost there, so if you fix it initially, you just have the cost, the man, the human power cost, et cetera, that you're doing it. But after the fact, you've got both the increased, cost to redevelop, et cetera. Plus, you've got maybe you've lost some sort of, your influence in the marketplace. You've got breaches. You've got all these other costs as well, and that's why that figure is so much higher. And then most enterprises today are still not integrating security into the development phase. So it shows you how big of a problem it still is and why you need to do something about it. And as we go through, so what do we mean by DevSecOps? So obviously people in the comments, you're familiar with what DevOps practices are. It's just a collaboration between developers and operation teams to help with faster software delivery, essentially, right? So it combines people, processes, technology, deliver continuous value to users, essentially a bit more marketing fluff in there. So, and then DevSecOps is basically just an evolution of this, right? Where the company takes on security first mindset, putting security into every phase of the development lifecycle from the very design all the way through to delivery, right? So when it's been implemented successfully, you gain both the speed of DevOps, it's still fast, and the holistic security and peace of mind from DevSecOps by integrating security into that. And so today's event, obviously, it's got a kind of Microsoft lens to all of this, but this isn't a Microsoft specific thing. All the terminology here, all the tools, etc., they exist. It's not just us. So the concepts are really important. So if I end up speaking about specific GitHub features, etc., just think about what it's protecting, and then that's what you need to worry about. So again, DevSecOps has some benefits that might seem obvious, as it reduces security risk. Like we mentioned, it's faster, it's cheaper to start, fix it to start than later. But still, even with all this, it's still been kind of slow to adopt, and part of that is due to there need to be some organizational changes, and you have to fill some knowledge gaps in order to really safeguard your environment. So and basically we have we have these different criteria for success that we kind of come up with here. So for developers and even CISOs, because you need that kind of buy-in from your security management as well for all this to be successful. So development teams, again, all about speed, productivity. Generally, these teams have 3 requirements. So they need to ensure developer velocity is maximized, so there's no limit to innovation speed. They don't want to add any increased complexity on developers, so you want developer-first tooling that's secure by design. And you want to involve developers in the security conversation and empower them to contribute. So not feel like they're just being kind of bossed around by security teams. They want to feel like a valued member and being considered in all of these conversations. And then for CISOs, the security management side, what they care about protecting company IP, your intellectual property, company data, secrets, etc., without impeding the development process. And their top 3 requirements reflect there's kind of a difference here, right? So they want to augment security practices with, really cool tools to kind of keep pace with evolving threats. They want that visibility across applications from testing to production. And to do this, they need to partner with developer teams to gain that, holistic visibility. And last, they want this ability to proactively hunt for threats inside, the overall workflow, instead of just acting reactively at the end, which is kind of what happens in a lot of instances. So fortunately, if you think about DevSecOps, it finds commonalities. It kind of combines those 2 together to find commonalities to help everyone work together. So one is, shared accountability. You hear that generally in cloud speech, right, about who is responsible for which elements of security, generally speaking. But here, it's like adopting security as a company-wide culture, tracking the right metrics. You got to think about security in the development environment, and which is one of the topics we're kind of going in a little bit more depth today. But limit development machines, infrastructure, and code bases, as being a potential attack vector. And then again, in the developer workflow. So you want seamlessly integrated security into the workflow. So developers are involved in security processes in a non-intrusive way. So it's not really making your life, much more difficult than it needs to be. But let's kind of talk about, for now, let's talk about security in the actual developer environment. So this kind of starts with, actual developer machines. And there's just a few sort of arbitrary groups we've got up here. So about securing cloud-based developer machines, right? We're talking about really these sort of 4 areas I got there. So for code browsing, when you're looking at, code repositories, etc., it's important when you can to limit scope for non-trusted repositories to a browser sandbox. So if that repository has somehow been compromised, etc., and then, however, that browser itself is sandbox out, so anything can't get beyond that browser sandbox. We also want to build non-trusted repositories in an isolated environment, not on a local development machine. And identity policy management is very important. So if you think about like coined repositories, right, they need to implement least privilege access principles. You need to make sure your accounts are protected by MFA. And then of course, secrets, if, whatever secrets you're using in config file, hopefully not inside a config file, but any type of secret, including encryption keys, etc., the ones you're using in development, do not reuse them in live, of course. I think that goes without saying. But when you kind of implement these correctly, you're defending your organization against some very common attacks, like executing malicious code in a developer machine, because if they do that, well, if you do that in isolation, it's not such a big deal. And attackers if you got that isolation as well. So what you often see is developers have this complete sandbox, but they've not isolated them, not like an isolated sandbox, a playground where if that machine gets compromised, often you'll see like a developed machine is like a jump box to further system. So they get into your machine, it's been compromised, and you use that to kind of expand lateral, that kind of lateral movement attack. So you want to have these controls in place to prevent those from happening, right? So there's like an example with one, there's just a few years ago. So there was an incident called ESLint and Octopus Scanner vulnerabilities. So Octopus Scanner, it infected other projects on like the very same machine as someone was using. And that's why if you're actually cloning an untrusted code on a machine outside, right, it's so risky. So it's no longer isolated, right? You spread that untrusted code, beyond your developer environment, right? So that again helps spread, that lateral movement, and it kind of really increases sort of attack surface there. So whatever you can kind of do to limit those. So there's a few other examples as well, but so basically, you want to secure the DevOps pipeline. So that first step, obviously, you need to make sure your workstations have been isolated properly, right? But you also need to secure the actual cloud environments you're using, which are part of this overarching, DevOps pipeline. So in order to secure development security alongside, keeping your developer velocity where it needs to be, you need a centrally governed and secure engineering system, control so that trusted, approved, and authorized DevOps pipelines and actors have the ability to enforce these supply chain controls, and ensure that your development from non-trusted pipelines will be controlled by denying production service. And if you do that, these changes basically fortify your organization against threats such as build tampering, where a software breach where people have tampered with your software builds without your knowledge, and that tampered build gets out in the wild. Unauthorized access to package repositories and production infrastructure, right? That code breach I referenced earlier, where they had an unsecured repository, right? So you need to make sure that your repositories are locked down. So not everyone has access, and you make sure you've got proper RBAC within your development. Your repositories, you've got least privilege, so the people with access have only the bare minimum of access they need to do the job, and you have appropriate security like MFA on there. So if your account somehow gets breached, like or your password, if you do have a password on your account, and so the password, it's in some sort of password hack, you don't know about it, they still aren't going to get in because you've got an authenticator or something on your account. And if you think about the overarching pipeline, you've got all of these different sections, these different components which are taken into account that you need to secure, right? So in order to ensure that your organization is producing verifiable and reproducible builds, you need to adjust security at every point, all the way from compilers through to the end where we've got, your actual build machine. So for compilers, right, you want to confirm that each compiler is signing properly with validated signatures, and make sure that there's some way to know that that is a valid signature, a trusted one, not some random signature you can't actually verify. So for build, right, make sure they are producing verified build manifests, that there's the inventory inside, so describing sources. You want cryptographic hashes of binary artifacts and full build parameters so you can verify if it's been tampered. You can build machines and infrastructure, right? You want to make sure these are very, very highly restricted with least privileged access applied, and you want ephemeral build agents. So that stuff is, it's not hanging around, right? It's gotta be kind of used and stored after the fact. And then DevOps services. So build and release infrastructure uses isolated managed identities and sensitive tenant profiles for isolation. So again, you keep seeing isolation mentioned again and again. And then compilers and user processes, again, they need to execute in isolation or lockdown environments. And then software on build machines themselves, again, signed properly with validated signatures. So if there is tampering at some point, you're aware. And so practices like these, again, so these protect you against a couple of different types of attack, like compromised compilers and build machines. So Electronic Arts, again, video game company, they had compromised build machines in their group and compromised dependencies. So there was a recent code-paid application attack where they had a software library dependency which compromised. And again, that spread through their overall supply chain. And then obviously code bases, and that's when you need to show that you've hardened access to these actual code bases. So in order, and I have allergies here, so I feel like I'm going to sneeze at some point. But in order to harden DevOps infrastructure, you also need to allow appropriate access to the actual code bases, right? So everything needs to have a maintainer. Please think in your organization, have some sort of logic to how you're doing this. I know the smaller the company, it gets maybe easier, but anyway, everything needs to have a maintainer. Least privilege access, it still works. So when it comes to inner sourcing, so read access and contributions are always okay. But you think about who can actually contribute, right? You need to have a tight control over that, and you should have some sort of approval workflow. So you want to make sure that contributions are approved by someone you've designated as the explicit owner for these code bases. And then limit elevated privileges, right? So you want to do so only when absolutely necessary. You want to do so as an use these elevated privileges only when absolutely necessary, and then like kind of try to give them a time duration if possible for those higher level of access. And you want to think of some changes to identity controls like this, because if you think about this, this is all around role-based access control, identity, etc. So these sort of changes protect you against source code exfiltration on developer machines, right? And source code tampering or injection of malicious code. So even if this happens, you've done this properly, you at least have that trail, so you'll be able to see who's done it, and be able to go back and at least fix it quicker if it somehow gets through. If you've not done this at all, right? You'll have, and some of this it talks about malicious. This doesn't even need to be malicious. People just make mistakes, right? So this gives you that traceability plus the protection.